Okay, so as I'm recording this, by the way, I just realized that if I want to get the desired sound quality, I have to put the mic really, really close. Otherwise, it'll just pick up the rest of the noise. So, okay, all right, is this close enough? We'll see. So, okay, welcome. As I'm speaking right now, there's a lot of noise outside because of construction. Okay, so yeah, so today's lesson is a continuation of yesterday. So yesterday we looked at the number families, right? And today we are going to talk about irrational numbers, okay? Moreover, we're looking at not just irrational numbers, it's actually rational numbers, but taking square roots of numbers, okay? So, yeah, someone just said hi to me. So, yeah, so that's what we're gonna do today. So hopefully we can do this in about 15 minutes, all right, the full lesson, and that'll be day two, okay? All right, so, okay, let's go right into the lesson. Okay, all right, so I got the mic so close to me right now. It's it's really like it's too close to me. The mic's way too close to me. Okay, all right. So let's start. Okay, so unit one, day two. All right. You can look at the announcements. I'm not gonna say anything about it. So let's see. Yeah. So here's the lesson for today. So this is what we've done so far, right? We talked about number families, rational, irrational numbers. We did this yesterday, and the lesson ended in this practice, so to speak, right? Where we talked about all of these square roots. By the way, another word that you can use for square root is radical. Okay, the symbol itself. So this is how you say it. With the number, typically people just say the square root. So this would be what's the square root of 4, square root of 9. The symbol itself is called a radical. Okay. Yeah, and the way they say it, you can actually say it in a couple of ways. You can say square root of 4 or radical 4. Okay, so if you ever hear teachers in the future, okay, in high school, and they say radical 4, that's what they mean. Okay, all right, let's move on. So practice day two. So this is basically the lesson and the practice. Okay, I want to get the idea to you very quickly, and then you can work on your homework in Delta Math. Okay, all right, so let's see. Okay, now here, right off the bat, you can notice, right, that this is not exactly a perfect square. So the difference between yesterday and today is that yesterday, at the end of the lesson, I gave you nothing but perfect squares, right? Meaning a number can multiply itself. Whole numbers that can multiply by itself to give you the number that's inside the radical. Right, again, I'll say that again. Two identical numbers, when they multiply together, right, multiplied by that number itself, will give you the number that's inside. Those are called perfect squares, right? Today, we're not using perfect squares. So think of it like this. Remember in 6th grade, right, you had to simplify this, right? Do you remember what the steps were? Well, how do you simplify this? Right, you find the greatest common factor, right, which is 2, right? The GCF was 2, and then you reduce it by dividing, right? It's the same idea here, more or less. We have to simplify. So when we do this, we're not solving anything. It's not an equation. There's nothing to solve. We're simplifying an expression. So another way of looking at it is like this, right? Hopefully when you guys did this partially in 7th grade, right, what would be the combined like terms answer? Right, it'll be 4x squared, right? Nothing to solve per se. You're simplifying an expression. So likewise, we are simplifying an expression here. That's all this is. How do we do that? We find something that is similar to the greatest common factor. Like how when we do fractions. Here's the trick. You would have two radicals multiply. So one of the first things I want you to realize is this. If you see something like this, that just means that the two numbers multiply by one another. 5 times 3 is 15. Okay? So likewise, your question is thinking to yourself, right? Self, what two numbers when I multiply will give me 75? Okay? Now, you can think of it like this, right? So you can think of like, what are all the factors of 75? Now, you could do 1 times 75. But the problem is that takes you nowhere, right? Because the square root of 1 is 1. And then you still have a 75 out here. So that didn't take you anywhere. So that's not a good solution, right, to your dilemma. What's another pair of factors that multiply to give you 75? Yeah, 25, right? 25 times what gives you 75? Right, 3. Right? Now, look very carefully. Is one of them a perfect square? Yeah, 25, right? What's the square root or radical 25? Yeah, 5. Nothing you can do. Rewrite. Simplest form. So you notice how I'm using that specific language from the 6th grade with fractions? That's exactly how we solve this. Okay, let's try a couple more. What about this one? What about 50? Right? Again, think of it this way, all right? Think two numbers that when you multiply will give you 50. Right? What two numbers? I think many of you thought. Now, 5 and 10 doesn't really take you anywhere because neither number is a perfect square. Right? So that's not going to help your cause. So think of another pair of numbers, factors, right? Yeah, 25 and 2, right? Now, you can write 2 and 25. I mean, you know, multiplication is commutative, obviously, right? So if you have 25 times 2, now, did you notice if there's a perfect square there somewhere? Yeah, 25, right? What's the perfect square of 25? Yeah, 5, right? And then just that. That's it, simplest form, nothing more you can do. Now, likewise, if you write like this will be 5. Now, don't write like that, okay? That's no one really writes like that. You still have to put the 5 in the front, right? Remember, right? Because when you have a number in front of another number in the way that I wrote it, right? It implies multiplication, right? Just like 2x to the third, right? Since there's no symbol here, it implies multiplication, right? Okay, all right. Now, if you're adventurous, you can start working on it as I'm explaining this to you, okay? That means you can save a little bit of time. If you want to see one more example, all right, just do one more example. Okay, here's another trick I do with students in class all the time. If you want to work on this, but you don't want to hear me talk and then like giving out answers, so to speak, you can press the mute button on your computer, okay, or in the video, and you can just work on it while I'm working. And when you look up, all right, if your answer matches mine, then congrats, okay? And if it doesn't match mine, right, my answer, look at the steps and see where your mistakes are, okay? All right, so let's think. So now I'm going to start talking. Okay, what two numbers when I multiply gives me 72? Now I can think of one, right? 36 and 2. So perfect square is right here, which is 6. 6. Oh, how do you say this, right? 6 radical 2 or 6 square root of 2. Okay, either way is fine. Okay, all right. Let's try, let's see. How many more? We got 2 more. You know what? What's the best way of doing this? You know what? Actually, so press pause right now. Do these 2 questions real quick. And then when you come back, I will show you the answers, and then we'll do some of those trickier questions on the right side. Okay, so I'm going to press pause right now. Okay, all right, and we're back. Now, here are the answers for these 2, right? So this is the first answer. Now, I wrote a or here because you can actually do it a second way, and I wanted to show you how, okay? Because sometimes the numbers get so big, like for example, the next one, it wasn't immediately obvious to me that it was square root of 25 times the square root of 6. Like, those are the factors. So, likewise, right, even with 32, and then this is a good way to show you. I mean, there's a point to make here, right? Square root of 4 times the square root of 8. So, now, because 16 times 2 gives you that 32 here, right? But so is 4 times 8, right? So, there's nothing wrong right now, Because, but only because this is a perfect square, and so is this. So we can keep the game moving, so to speak. We can keep reducing, like how you reduce fractions, right? Because you don't always use the GCF, not always, right? So here we got 4, so that turns into 2. Now here's the thing though. I got 8 here. I can break the 8 down a little more. What times what gives you 8? Right, 4 and 2, right? So look, what's the square root of 4, right? That's a perfect square. 2. You see that? See what's happening? 2 times 2, 4. 4 square root of 2. Same answer. Okay? And that's how we know that we can do that. Okay? All right, let's see what else. So that's the answer for this one, right? Okay, so right now I want to show you a couple of tricky questions and then see if you can handle these yourself. So why don't you press pause right now? Do the first, so you notice how it's like here I have a typical way of thinking. So these are very, by the way, just so you know, all these questions come from all regions exams. So if you can handle these questions over the course of time, by the time we go to June, you can handle the regions fairly handily. Okay, so have confidence in that if you keep watching these videos every day and you keep practicing with regions questions, you're gonna do well on the exam. Okay, so all right, so these are, so when I show you, there's usually like what a very traditional question, conventional question would look like, and when I show you these, it's a different way of looking at the same questions. It's a different way for them to ask you guys all the same questions. Okay, so with that said, why don't you guys try these 2 right now? Okay, because they both look kind of the same. So I'm gonna press pause. When you come back, we'll go over it. So press pause right now. Okay, and we're back. So here we have a question, right? They're saying, hey, look, I simplify this. So I simplified this. Now, I technically did not show you how to do this. Okay, so I'm reaching here a little bit, but I thought it would be good for you to at least think about it because that's actually tomorrow's topic. Okay, so here now, we simplified it, so watch this. So that's why I did only part of it. So here we got 5 times square root of 20, right? Nothing crazy here. Here, I'm gonna break this guy down, right? Interesting, right? Looks like a little like a factor tree that you guys did in 6th grade. What times what gives you 20? 4 times 5, right? That's a perfect square. So what does that mean? Bring down to 5. So you see how this is a culmination of a lot more topics than you think, right? Factoring, factor trees, we're simplifying, and here we're bringing down all the, what do we bring down? We're bringing down each sentence as we rewrite them, right? So that's very similar to our order of operations in solving equations, right? So you see how all these things are coming together now in the 8th grade. So here we got 5 times 2, that's 10. 10 square root of 5. What do they want? They want to know what the outside number is. It's 10. Okay? All right. So next one, I just realized I gave you this also here, but that's okay. All right? Same idea. What's A? A is 6. Okay? Hold on, let me pause first. Okay, all right, let's see. Now, I want to show you 3 trick questions. Nothing you can't do, by the way. I have full confidence in you all being able to solve this. So press pause right now. We're doing great on time, so I think we're gonna hit the 15-minute mark today. Wow, okay. I'm very happy about that. Okay, all right, press pause right now, try these 3, and then we'll be done for today. Okay, so press pause right now. Okay, all right, and we're back. So let's go over these 3 questions. Okay, this one now, don't get thrown off by the fact that there's a big fraction inside. Okay, don't get thrown off because what you're really thinking is this. I'm gonna rewrite it as such. How should I write this in like a nice way that you guys can really see? Okay, I know. Do this. Okay, so the question really is, what times what gives you 121? All right, I talked about this yesterday. Yeah, 11, what times what gives you 144? Yeah, there you go, that's it. right? Because if you take this and you, let's say you square it, right? You get 121 over 144, okay? I think we probably did this in 6th grade also, right? Okay, there you go, okay? Now this one, not as tricky as you think, right? Because you got a negative sign outside, right? Now, you already know why you can't have a negative sign inside, right? Because we talked about this yesterday also. That can't happen. It's an imaginary number. So we're not there yet, right? So all you have to do is take the negative sign and then just take the square root of 64, which is what? Yeah, square root of 8, right? Okay, all right, what else? Oh, I really like this one, actually. One of my favorites. This one, how are we doing on time, by the way? Yeah, we're good. Okay, so square root of 0.49. Again, don't get thrown off by the decimal, okay? Because now what you really got to think is, right? What times what gives you 0.49? Now, think about it first. What times what gives you 49? Yeah, 7, right? So you know it's not these guys, right? Not A and D, right? So it's 0.7, 0.07. So here's the thing, right? What times what? By the way, if you want to use a calculator, you can do 0.7 times 0.7, or even rather, you can put this into your calculator, right? You can put this in there and it'll give you an answer, right? And that's 0.7. Now, you might say, hey, Mr. Ng, how is it possible that 0.7 times 0.7 will give you a number that's smaller? But you got to remember, any number less than 1, right? If you multiply by another number that's less than 1, the answer is even smaller, right? So that's why 0.7 times 0.7 is 0.49. It's you're taking a part of something and then taking another part of something. So of course you're gonna get like a part of a part, which makes this number small, okay? So that's that, all right? 15 minutes, not bad, all right? Just as promised. Thanks for watching. Have a good day. Do your Delta Math homework, and I will talk to you guys tomorrow. Okay? Oh, not tomorrow. Is today Friday already? Yeah, so it's Monday. Oh, do we have school Monday? No. Haha, great. All right, so yeah, the following Tuesday. Yeah, so enjoy your 3-day weekend. All right? You made it through the first week of school, and that's fantastic. Okay? And yeah, okay. All right. I'll talk to you guys later. Bye-bye.
OMG, that was so good.